Okay, so the distance formula kind of takes what we did in the last class with finding the length of a vertical line and the length of a horizontal line and combines it with the idea behind Pythagoras' theorem. So if we look at this first question, we have a line segment AB with the coordinates of A being -5 and -3. B's coordinates are 7 and 6. So if we were to use the Pythagoras theorem, what we would do is we would make a right triangle, because that's what we need in order to use Pythagoras. And we would find the length of the two legs. So what is the vertical leg? What is the length from B to C? 9. And the horizontal length from A to C? 12. So using Pythagoras' theorem, how would I write that? How would I find the length of AB? So 12 squared plus 9 squared, and that will give me AB squared. So what is 12 squared plus 9 squared?
15.
It's not 15.
Oh, it's 225.
It's 225.
Screwed, it's 15.
And then when I square root it, I get 15. Okay. But what if we couldn't graph this? What if we didn't have grid paper, or we didn't want to actually have to go through and figure out the horizontal and the vertical length? Or perhaps the line is quite a long line, and so the horizontal and the vertical lengths would be large numbers. What could we do then? Well, if you remember from the other class, when we were calculating the length of the horizontal lines, we subtracted coordinates. Okay? What are the coordinates of point C? Look at the coordinate of B and look at the coordinate of A and tell me what you see in relation to the coordinates of C.
Whoa.
So if I look at the coordinates of A and C, what do you notice? The y coordinates are the same. And if I look at C and B, the x coordinates are the same. So from the last class, if we had coordinates of a horizontal line, we subtracted the right coordinate by the left coordinate. So 7 minus -5, which equals 12, which is what we got when we counted it out. And then the length from point C to B is we subtract the top from the bottom. So 6 minus -3, which is 9, which again is what we got when we counted. So when I use Pythagoras' theorem, I have this 12 squared, which is actually the difference in the x coordinates from B and A. X coordinates, -5 and 7, because remember this 7 is actually the same in both B and C. And then the difference in the y coordinates from B and A, again, that y coordinate is the same as A. So without using this point C, I can use these 2 points to still get my 12 and 9. 7 minus -5, 6 minus -3. So the difference in the x coordinates squared plus the difference in the y coordinates squared gives me the length of AB squared. So what we do is instead of writing difference in x coordinates, difference in y coordinates, we put it in xb minus xa squared plus yb minus ya squared. Just means pick a coordinate, subtract. Pick a coordinate, subtract. So I get 7 minus -5, which was my 12 squared, and then I get 6 minus -3, which becomes 9 squared. Together gives me 225, and I still get 15. So what we're doing is we're using Pythagoras' theorem to find the length of a line using just the coordinates. So we're not dropping this down. We're not going to make a right triangle. We're going to use the coordinates. So the length of this line is going to be using Pythagoras' theorem, a squared plus b squared equals c squared. This is my c squared. So to get my a and my b, my two legs, I can take the difference in the x coordinates, x2 minus x1, and that'll give me a horizontal length that I can then square. And then I'll take the difference in the y coordinates. y2 minus y1 squared. And then if I take the square root of the sum of those two squares, I'm going to get the length of AB. Okay. I would give you the distance formula, which is on the next page. I would give that to you on a test to be able to use. So you don't have to memorize the distance formula, you have to be able to use the distance formula. And because I'm squaring the difference in the coordinates, it doesn't matter about taking the top coordinate and subtracting it by the bottom, or the right and subtracting it from the left. Because if I take -6 and I square the answer, I'll get the same thing as if I took +6 and squared to get the answer. What matters is just being consistent. So if I use this distance formula, the difference in the x's, and the way that we can write this out is we can actually go distance of PQ. So the difference in the x coordinates, it doesn't matter if I go 2 minus 10 or 10 minus 2. Which way do you guys want to write it? 10 minus 2. Okay. So it'll be 10 minus 2 squared plus the difference in the y coordinates. Because I chose 10 first, I need to choose -3 first. That's what I mean by being consistent. So I have to write this as -3 minus 3 squared. So what is 10 minus 2? 8. And what is -3 minus 3? -6, right? So what is 8 squared? 64. -6 squared? And what is 64 and 36?
100.
And what's the square root of 100?
10.
Okay, so I'm going to give you a moment. I want you to try to do B on your own. So the distance from G to H would be the square root. So how did you write it in? What did you write, Taylor? Did you go -25 minus -17 or -17 minus -25?
Yeah.
This way?
Yeah.
Okay.
Then plus negative, or yeah, -5 and -3.
Okay. So it would be -5 minus 3.
Yeah.
Okay. So what is -17 minus -25? 8. So I get 8 squared. And what is -5 minus 3? -8. So both of these are going to give me 64. So it doesn't matter that I had a -8 there. When I square it, I'm going to get a positive 64. So I get 128, which is not a perfect square number. So if I want to find the exact length of this line segment, it's exactly equal to the square root of 128. Although I should check, can I divide 128 by a perfect square? So can I divide it by 4? What do you get? 4 times what?
32.
Is it 32? Okay. If I can divide it by 4, should I check to see if I can divide it by 16?
You can.
16 times what?
8.
And if I can divide it by 16, I should also check to see if I can divide it by 64. 64 times what? 2. And the square root of 64 is? So the exact answer would be 8 root 2. Okay, so we have one more question. So sometimes we impose grids on a map to find the distance between 2 locations. So for example, if I was looking on the moon, I could calculate the distance between 2 craters, Copernicus and Pluto, by superimposing a grid on the map of the moon. Ordered pairs are then assigned to both Copernicus and Plato to find the distance. If the location of Copernicus is at -89 and 226, and the Plato is at 136 and 179, find the distance between the 2 craters. So I'm going to get you to do that for me first. So if we find the distance between Copernicus and Pluto, I would have 136 minus -89 squared plus 179 minus 226 squared. So when I find the difference between 136 minus -89, I get 225, which I can then square. And when I go 179 minus 226, I get -47. If you had inverted these numbers and you went -89 minus 136, you'd get a -225, and you get a positive 47 this time. So it just means that the numbers, the negative sign would be the opposite, or the sign would be the opposite. So this gives me 52,834, the square root of which ends up being 229.85, which I can write as 230 units. I would then need to know what the physical measurement is of each unit. Does each unit represent a kilometer? Does it represent a mile? What is each unit on my grid? Okay, so let's look at the last question. Explain how we can determine if a triangle is right-angled. How do I know if I have a right-angled triangle? Brianne?
Just use Pythagoras' theorem to solve, to see if it adds to the hypotenuse.
So the square of the longest side has to be equal to the sum of the squares of the other 2. So in B, L, M, and N are 3 points. If I join those 3 points, I want to prove that this triangle is right-angled. So in order to prove that, I need to find the length of the 3 lines. So I'm going to give you a couple of minutes. I want you to find the distance from L to M, M to N, and L to N. So find the distance of those 3 lines for me. Okay, so let's look at the lengths of these lines. So from L to M, let's see, 0 minus -3 squared plus 1 minus -3 squared gives me 3 squared plus 2 squared. So 3 squared plus 2 squared, which will give me the square root of 13. So then I get 9 plus 16, which would be 25. So square root of 25 is 5. Then from m to n, let's see, negative 3 minus negative 7 squared plus negative 3 minus 0 squared. Negative 3 minus negative 7 is 4. So I get 4 squared plus negative 3 squared, which is still 25, which is still 5. And then from L to N, I get 0 minus negative 7 plus 1 minus 0. So I get negative 7 squared. So negative 7 squared plus 1 squared is the square root of 50. So if this is right angled, it means this squared plus this squared has to equal that squared. So what's 5 squared? 25. And what is the square root of 50 squared?
50.
It's 50. What are these operations called? Squaring and square rooting are inverse operations. They undo each other. So 25 plus 25 equals 50. So I have proven that this is right angled. This right here ends up being my hypotenuse. So questions 3A, 5, and 6, and then 9 to 12.